In this video, we're going to be looking at some revision of trigonometric concepts. So what we're talking about when we say trigonometric concepts are circular functions and circular equations, sort of basically things to do with angles, degrees, like sine, cos, and tan. So the first thing is measuring an angle. So if we have, so that's a unit circle here, we'll go over in a sec. But just to begin, if we have two lines, so we have a line there, and we have a line going up there, there's an angle in between those lines. So there's angles throughout everyday life, they're everywhere. So there are two main different ways to measure an angle. Firstly with degrees, which you should be familiar with as it's the most common, and less to get more into mathematics. But that's because there's 360 degrees in a circle. And that's where obviously like the skateboarding term 360 comes from. So there's 360 degrees, so that means a semicircle is going to be 180 degrees. Two lines that are straight have an angle of 90 degrees, so they're perpendicular. And then you can have different angles here, so it's like 45 degrees, and so it varies. And then 1/360th of a circle, so a very, very small angle is 1 degree, and then obviously it continues up. Then you have 90 degrees, 180 degrees, 360. So 45, 90, 180, 360, and 60 degrees. So like the big numbers like that are the most common you're going to deal with when you're looking at degrees. So you have 360. But then we are introduced to another concept called the radians. So radian is another way of measuring an angle. So it comes from, if we're looking at a circle, well, firstly a circle has a center, and then at every point from this center is the same length. So along here, that length is x, then along here, that length is x, and this is how a circle is defined. Every single point on the circle to the center origin has the same length. So a unit circle has length of 1. So looking at this, that means that point here is 1, 0, 0, -1, 0, 1, and there is -1, 0. But it also means that if we take a point along here, that's going to be length 1, and obviously all these are going to be length 1. Now if we go from this point, and we go along the circumference of the circle 1 unit, so let's say 1 unit, and then we match this up, then this angle here is defined as 1 radian. So if it's 1 unit across on the unit circle, and then 1 unit along the circumference, that's going to be 1 radian. And then that is what's defined as a radian. Then in total, so like before, like the whole circle or 300 was 360 degrees. So the whole way around is 2 pi radians. And if you remember, pi is about 3.14, so that's like approximately 6.2 or 6.3. But you don't need to know the exact value, but you just need to know it's obviously a lot smaller than degrees. But along the whole circle, it's going to be 2 pi radians. As you can see here, that is a symbol for radians, but often you don't write a symbol for radians, but for degrees, you basically always draw that circle. And then with radians, sometimes you may leave it off. So you don't really know how a radian is defined. You just need to remember that 2 pi for the whole circle, and then you can sort of cut it up from there. And then later on, you'll need to memorize the key or learn the key angles in both radians and degrees. So if we know that 2 pi is a whole circle, then we can work out what the equivalent radians and degrees are. So you have here, you have 180 degrees is 1 pi. And that's because if a whole circle is 2 pi, then 180 degrees is half a circle, and half of 2 pi is obviously pi. Then 90 degrees is half of 180, so it's going to be pi on 2. And if you think about pi on 2 times 4, gives you 2 pi. 60 degrees is pi on 3, because if you're splitting 60 degrees, it's like this. So you have 60, 60, and 60, which add up to 180. So that altogether is pi. And then divide that by 3, you get pi on 3. So 60 degrees is equal to pi on 3. 45 degrees is equal to pi on 4, so a similar thing. But instead we're going to have split up into 4. And then 30 degrees pi on 6, same thing, but now splitting it up into 6. But yeah. So you should be able to say, so these are the common ones, and just make sure you're familiar with those. Conceptually think about why these are the case, and then know those. But what about if we want to convert, let's say, 57 degrees? So we have 57 degrees. So what is that in radians? So we can convert back and forth. So thinking about 360 degrees is equal to 2 pi. So what does 1 degree equal? Well, we can divide both sides by 360. So if we divide that by 360, and we divide that by 360, we get 1 degree is equal to pi on 180. And that's a small number. And that's because obviously 1 degree is very, very small, and then radians, like 1 radian is bigger than 1 degree. So that means this number is going to be quite small. So converting however 57 degrees, we can think about that as 57 degrees is equal to 1 degree times 57. So that is equal to 57 times pi on 180. And that will give us 57 pi on 180, and that is in radians. So to convert from degrees to radians, we times by pi on 180. And a good way to remember it's pi on 180 is that this is a small number. With degrees, obviously degrees are normally big numbers, so when you convert it to radians, it's going to get smaller. So that's why I need times by pi on 180. But what about if we wanted to convert from radians to degrees? So from radians to degrees. If we have, well, it's going to be the other way around now. So we're going to have to times by, instead of pi on 180, 180 on pi. So if we're going from 2 pi, times that by 180 on pi, and we get that is equal to 360 degrees. And we'll see how we've already shown that 2 pi degrees is equal, 2 pi radians is equal to 360 degrees. So because you're dividing by pi, often radians are in terms of pi. So when the pi's will cancel out and you'll get a more exact number, which is often with degrees, you don't normally have pi in the terms, but you can. So with radians converting, this is obviously a bigger number because pi is like about 3, so 100 on 3 is obviously going to be quite a big number. So because degrees are much bigger than radians, when you're converting from radians to degrees, the number's going to get bigger. So that's a good way of thinking, which one does it have to be? Well, it has to be 180 on pi. So if you want to go from radians to degrees, you times by 180 on pi. And if you want to go from degrees to radians, then you times by pi on 180.